Hey guys, hope you're having a good weekend. Sorry the video's late, but hopefully this will help a little bit. It'll be a quick video, just going through the notes and talking through them, and we'll talk about them in class tomorrow. Uh, so let's just get going through this. If you read the example, it says Miranda babysits to earn extra money to play select soccer. She charges $10 supply fee for activities and games and $5 per hour that she babysits. Using information about Miranda, complete the table, graph the information on the graph provided. Be sure to label your axis, then answer the questions that follow. Okay, so what's going on here is we got Miranda, she's babysitting. She charges $10 straight up. That's for activities and games. So it's a $10 fee, guaranteed. That's what we call an initial value. That's not going to change. And then she also charges $5 per hour. Notice it says per hour, so it depends on how many hours. Well, that is what we call a constant rate of change, and we'll get that in just a second. So it wants us to fill out a table. It wants us to make a graph. I did that. Your X values, that's the number of hours. So working 0 hours, 1 hour, 2 hour, 3 hour, 4 hour, 5 hour, and so forth. Your Y is the total amount of money that she earns. Well, looking at our notes here, the independent variable is the hours babysitting. The dependent variable is the money she earns. So how much she makes depends on how many hours she works. And you can see the table, we can fill it out. Well, if she worked 0 hours, there's still that initial value of 10. Right here, there's still that initial value of 10. Initial value of 10. Okay, and then plus $5 an hour. Well, if she worked 0 hours, that would just be $10. Okay, if X is 1, so if she worked 1 hours, now we're just plugging in 1 for X. So again, you got your initial value of 10 plus $5 per hour. She works 1 hour, so that's 10 plus 5 be 15. And you can see the pattern that's developed. The number of hours she works, we just plug it in to our equation here. So using this equation, we can figure out how much she would make given the number of hours. So again, independent variable, that's our X value. You need to start remembering, if it's independent, that's X. Independent X, dependent is Y. The Y is dependent on X. So in this case, the amount of money she earns is dependent on the number of hours she works. And you can see that, money earned, number of hours babysitting. Depends on the number of hours babysitting. All right. The constant rate of change. Constant rate of change. So it's basically saying how much is it changing, and it's constant. So it's going to be the same amount changed each time. Well, give it in this problem, it says it changes. She's getting charged $5 per hour. She charges $5 per hour. So the constant rate is $5 per hour. So the constant rate of change is $5 per hour. The initial value, that's how much she starts. I mean, that's the initial amount. Well, she charges $10, and it says for supplies, for a supply fee. But she's going to charge everybody $10 straight up, guaranteed. That's your initial value. Initial. Okay. Your function, you could see it how we got the table. Your function would be y equals 10 plus 5x. You could also say the amount of money she earns equals $10 plus $5 per hour. You could also write it in our function notation, f of x equals 10 plus 5x. Same thing. Those two are the same thing. All right, domain and range. Okay, domain is x. Range is y. All right, domain. Let's look at our problem. Domain, x values, x values. So look right there. There's your table right there. There's your x's. So if make sure you see this, that it says her domain for the situation if Miranda earns $50. So what are the x values that she could make up to $50? Well, and that's in this problem, that's the last one we get. So the domain, the x values, that's 0, 1, 2, 3, 4, 5, 6, 7, 8. Your range, your y values, she's been babysitting for 4 hours. This is actually not right. for 4 hours. Okay, well, hours, 4 hours. She's been babysitting for 4 hours. Then I need to change this. I put all of them in there. That's a common mistake. Common mistake. So make sure we notice it's asking the range if she babysits for 4 hours. So you don't have to go all the way out here 5, 6, 7, 8 hours. You can stop at 4 hours. Okay, the range is the Y. So when I go out to 4 hours, I go up, that's 30. So this right here, I could have stopped at 30. All right, so let's look at this again. What is the reasonable range for the situation if Miranda babysits for 4 hours? So again, like I said, I'm going to go out to 4 hours, and then what is the Y value? Because remember, range is Y. Well, the Y is 30, so that means all the way from 10 was the first. She worked 0 hours, that's 10. 15, she worked 1 hour. 20 if she works 2 hours. 25 if she works 3 hours. And 30 if she works that full 4 hours. So your range in this case would be 10, 15, 20, and 20. 10, 15, 20, 25, and 30. All right. Next page. Similar example. Same steps we're going to do. I'm going to go through this a little bit quicker. You can rewind if you need to see it again. It says Video City charges $3 to rent a video. So that right there is going to be your initial value. Because that's how much that's guaranteed. They're going to charge you $3. And then they're going to charge you $2 per day. Notice it says per day. Per day. The last example was per hour. That is going to be your constant rate of change. So you got $3 to rent it, and then a $2 per day for late charges. So every day you're late. And I hate late charges. That always happens to me for some reason. But late charges, $2 per day. That stinks. Use the information, complete the table, graph the information provided, be sure to label your answers, then answer the questions. Okay, so let's complete the table. If you rent a video and you keep it for 0 days, well, you're going to get charged $3 to rent a video, and it's not keep it for 0 days, but if you're 0 days late, you rent the video for $3, you're 0 days late, so that would be nothing. So you would pay $3. Okay, what if you were 1 day late? Well, you still rented the movie. That's $3 plus the $2 late fee for that day. So that would be 3 plus 2, 5. What if you were late 2 days? Well, now you still rented the movie, so you still have the initial value of 3 plus 2. And how many days late was it? It was 2 days late. So that's $2 per late day. You were late 2 days, so 2 times 2 is $4 for the late fee. Plus the $3, that's $7. You can see it's the same steps. If you were 3 days late, 4 days late, 5 days late, 6 days late, 7 days late, 8 days late. Okay, independent, and then you can see the graph. I got my axis labeled. Got down here, I should put late days. And up here, this right here is the money. All right. Independent variable. Remember, independent's your X, dependent is your Y. Independent variable X. What did X represent? It represented the days late. It represented the number of days late. Okay, your dependent, your Y, that's your cost. That's your money. That's the money. That's the cost. $3, $5, $7, $9, $11. That's the total cost for you to rent that movie with the late fees and everything. Okay, so the money depends on how many days you were late. The money depends on how many late days you were late. Constant rate of change in this problem was $2 per late day. It says it right there, $2 per late day. If it ever says per day, per hour, per month, per year, that's going to be your rate of change, your constant rate of change. Your initial value was $3. You were going to get charged $3 to rent the video, regardless of how many late days you have. So that was the initial value. Your function, it's what we use. It's the same thing as what we use to find these values up here at top. So your function is y equals 3 plus 2x, or you could say f of x equals 3 plus 2x. Same thing. All right, domain. Again, domain is x, range is y. Your domain, the final cost to rent the video is $17. Okay, so let's go up here to $17. Remember, this is money. So here, 16, 18, so that's going to be right here in between. I'm going to go over There's my point. If I go down, that was my actually a little bit. That's 1, 2, 3, 4, 5, 6, 7. That would be day 7. Day 7. You'll see that right there. Day 7. So my domain is my x values. So up to day 7. So I'll go 0, 1, 2, 3, 4, 5, 6, 7. That would be my domain. Your range is your y values. It's your y values. Okay, it says what's a reasonable range if you keep the movie for 3 days. Okay, so here's my, remember, these are my days late. So these are my days. I'm going to go out here. Okay, there's 0, 1, 2, 3 days late. Go up. There's the point. The y value that point is, it's between 8 and 10, so that's 9. You can also see it from your table over here. 3 days late, 9. So I'm going, my range, my y values is going to be 9, 7, 5, and 3. And you can see range. Okay, guys, we'll talk about this in class tomorrow. Hope you have a good weekend. The rest of the day. I'll see y'all tomorrow.